Hi, welcome back to the Nav Station. I'm Andy Howe. Here at the Nav Station, our goal is to get you confident enough to head out in the ocean, turn off your GPS, and get to where you're going with celestial navigation. Well, here we are at the final stage of a typical site. We've looked at the theory, which we keep in our mind all the way through the process. We've corrected the site. We've gone in the Nautical Almanac and extracted the GHA and the declination for the time we took our site. And we've used all that information to get us into the site reduction tables, where we've pulled out some key information which gets us onto the chart. And that's what we're going to do in this episode. We're going to look at setting up a universal plotting sheet, putting some of the site information we've extracted from the process onto the chart, and talk a little bit about what you do with it going forward. We'll have a more involved episode on just plotting, and that'll be coordinated with our day at sea examination. But first, let's do a little review of the elements of plotting. There is a hierarchy of positions, most of which we utilize in Celestial, some of which might be new to you. So let's go do a quick review. The first is the dead reckoning position. This is the most elemental position in navigation. We've been talking about it all the way through. Dead reckoning is nothing more than an estimate of your position based on your course and your speed, nothing else. And the DR plot on your chart should be kept up on a regular basis, whether it's every hour, every 3 hours, every 4 hours, whatever seems to work with your passage. In the middle of the ocean, you don't need to keep an hourly plot of DR, but you do need to keep it up regularly, because every time you take a site, you have to pull a dead reckoning position out and use that in the site reduction process. The proper symbol for a dead reckoning position is a half circle over the position. This is convention, and that's what we'll be using going forward when we do plotting. The next position in this hierarchy is called an estimated position. Now, an estimated position takes the dead reckoning position and adds one or more pieces of information to it. For example, you might have a dead reckoning position as you're approaching the coast, and you would take a sounding, and that would be enough to create an estimated position. It might be taking a dead reckoning position and taking a compass bearing to a lighthouse or a feature on shore that's on the chart, and you create a line of position that will run across your chart, and then you use your DR to calculate where your EP would be. Similarly, with celestial navigation, one site gets you one line of position. So when we get one line of position, we're going to create an estimated position for that time. The symbol for an estimated position is a square around the position. And then we have a whole host of what we will call fixes. We'll use in Celestial a lot a running fix. And a running fix, like every fix, is denoted with a circle around the position. Now, a running fix is nothing more than taking information from a few hours ago, not terribly far back in time, and advancing it to your present dead reckoning position to combine with a current position information. In Celestial, we're talking about sun lines. We take a sun line at 8 in the morning, we take another one at 9:30 or 10, we advance the 8 o'clock sun line to the 10 o'clock dead reckoning position, and we create a running fix where those two lines of position cross. And we'll look at that in more detail as we go further. Now, a fix can also just be a plain fix. For example, you take a whole series of star sites and they all cross at one point or almost a point. You call this a fix as well. So the symbol is the same, it just gets labeled. In this case, it would be a star site fix, and you'd have all the LOPs labeled for each star. If you're using your GPS, I know it happens, the symbol for an electronic fix is a triangle. Now that distinguishes it from other fixes which might use a bearing or a line of position, as in celestial. The other position that we have brought into play here is the assumed position, which is nothing more than our DR position manipulated to fit certain rules. It uses the same symbolism, and typically you use it to construct the line of position. You don't have to leave it on the chart unless you want to refer to it later to make sure you didn't make a mistake. But it's not really a navigational point. It's really a construction point to allow you to create that line of position. So these three, plus the assumed position, are the ones we're going to be using most in our celestial day. If we're lucky enough to get good star sites, we might use a star site fix like that. So that's the basic overview, so that we understand when we put symbols on the chart what they mean and how important it is to distinguish one from the other. Another convention that many people will practice in different ways is the way to label a course. And let's say this is your course. Some people like to put the course direction on top and the speed underneath, so you can create your dead reckoning position based on that. It's really just a reference, whatever seems to work for you, so that when you look at your chart and you're looking at all these lines, you know that a course line on which you create your dead reckoning plot, you can identify what that course was and the speed was for that particular segment in time. There's no real right or wrong to it. It's just however you choose to label it. Okay, let's talk about what we get out of the site reduction tables and what we're going to do going forward to get onto the chart. We come out with pieces of information, the dead reckoning position. That's number one. We have that to start with. That gets us going in the whole process. Number two, we take the DR position and we manipulate it so we have an assumed position. We need that to both get into the tables, the site reduction tables, and to be able to get onto the chart to make our final plot. When we go into site reduction tables, we come out with the ZN, which is the true bearing to the body, whatever the body might be. The second piece of information we get out of the site reduction tables is our HC, or calculated altitude. The altitude and the bearing we would have seen if we were standing at the assumed position. That's what our sextant would have read, and that would have been the bearing to the body. Lastly, we take our HO from way back in the site correction process, our observed altitude, and we compare it to the HC, the calculated altitude at that assumed position. The observed altitude is the altitude we actually observed wherever we were, and we're comparing it to the assumed position. As I said earlier, usually they're not terribly far apart, they're not terribly different, but sometimes they can be 20, 30 miles different. So when we compare those two, we find the absolute difference and we create the intercept. Now the intercept is labeled away or toward, indicating that if you start at the assumed position, which is where the calculated altitude is measured or would be measured, which way do you move to get to your observed altitude? Do you go towards the body, which means that you observed a steeper angle, or do you go away from the assumed position in the opposite direction of the bearing, which is where you would get to a smaller value on your sextant? Once we do that, very simply, we're going to plot our assumed position. We're going to draw a ZN that points to the body, and we're going to move either towards or away, and at one of those points we'll draw a perpendicular line, which will be our line of position. This distance here or here is merely the difference between these two readings, these two altitudes. The minutes difference here is automatically mileage, nautical miles. Remember way back in our beginning segment of this series, we talked about the relationship between altitude and miles in distance, and that's where this comes into play. Just subtract the smaller from the larger, we get the intercept distance, and it's nautical miles. So this measurement is the intercept, and then let's say that a DR is over here, and we would pick the closest point on the line of position to the DR as our estimated position. And that's what we're going to do on a regular basis with every site. The assumed position and the bearing line, the ZN line, again, are just construction lines. As you get more comfortable with the process, you may just make this a faint dotted line and just use it to get this LOP constructed and then erase it, and that's fine. As long as you're happy with the result and you're certain you didn't make any errors. So that's what we're going to do on the plotting sheet. We're now going to set up a plotting sheet, do a couple of examples. We'll save a lot of the running fix examination and things like that for a later episode, but we'll get to the basics of plotting a site next. Okay, so here's a universal plotting sheet that we'll use for every single site that we need to plot. It's the most efficient way to plot a site rather than putting it onto a navigational chart. You can use these for a day or two for a voyage and get a couple of days worth of celestial sites plotted onto them. A few features about each plotting sheet. We have a central compass rose here, which is measuring true degrees, that is from 0 degrees all the way around to 360, no variation on this plotting sheet. There's a central line of latitude, which I've labeled as 30 degrees north, and there's a central line of longitude that I've labeled as 65 degrees west. The central line of longitude also has the increments, the minutes of latitude noted, which is also equivalent to nautical miles. So we have a nice big mileage scale right in the center of the chart. Down here in the corner, we have the longitude scale, showing us that at the equator, the lines of longitude are at their furthest apart, and as we converge towards the poles, the lines of longitude get closer and closer to each other. This particular scale allows us to set up for any latitude, any mid-latitude so-called, from 0 to 70, and then to pick off your minutes of longitude along the scribed line, which I've scribed in for 30 degrees of latitude. So to get started, the first thing we need to do is label the other lines of latitude. So moving north, we'll go to 31, and moving south, we'll go to 29. Next, we're going to have to plot our other lines of longitude. And there's two ways to do that on every chart. One way is to take your dividers and span the entire distance along your scribed mid-latitude line. The scale is set up with a 0 point here and 10, 20, 30, 40, 50 minutes, and then the final 10 minutes is off to this side, scaled off in 2-minute increments. So if we take that entire distance, we have 1 degree of longitude, and we can just make a couple of points and then connect the dots. To draw in our (66°) west line of longitude. The other method, which is a lot easier, frankly, is to use the compass rose. Note that the compass rose on the outside ring has increments of latitude marked off 10, 20, 30, 40, 50, 70, top and bottom. So if we find our 30° mid-latitude point there and our 30° mid-latitude point there, we can again connect the dots. Line this up straight, and we have our 64° west line of longitude. You can draw in additional lines if you need, but for now we'll just do these 3. Next, we need to plot our dead reckoning position, because that's something we will have already taken off the chart for our site in order to reduce it properly. So the DR is 30 degrees 20 minutes north, and we'll line up the edge of our rolling plotter here at 30 degrees 20 minutes north, and we'll take 64 degrees 34 minutes west. So down here we'll put 1 point on the 30-minute mark and then go over 2, 4. So we have 34 minutes total here. And we can just plot that down. And there is our DR, whatever time it might be. Next, we would be plotting our assumed position. And our assumed position is always on a whole degree of latitude, so we know it's along this 30 line here, because that's what we've noted as our assumed position. And it's 64 degrees 50 minutes west. So we'll just take 1 point at 50, the other point over at 0, and we've got 50 minutes here in our dividers, and we can just put 1 point down at 64, and then over here is our assumed position for this particular site. Next, our zenith line, our ZN line rather, our azimuth angle, points to the body and to the geographic position of the body, and that is labeled as 320. So we'll line up for a compass direction of 320, roll that over to our assumed position, and draw the ZN line through the assumed position. This points, I'm going to call it a sun line, so it points to the sun, or to the geographic position of the sun, which may never be at 320 degrees, but for this exercise it's fine. Next, the intercept is 10 nautical miles towards, so we just measure 10 off of our mileage scale here, go from the assumed position towards, get that again, make a mark, and at that position, that's where we're going to draw our perpendicular line for our line of position. So we'll take a perpendicular to the ZN line, and then right through here is our line of position for this particular site. And this line of position is part of that great big circle with the geographic position of the body somewhere out here, and we are somewhere along that line. What we do with one line of position is take our dead reckoning position and pick the point on the LOP that's closest to the line of position. And that, by definition, is just a perpendicular line. And at that point, we draw in a square representing the estimated position for this particular site. And that is plotting. From this point on, whatever our course was, we would start from the estimated position and plot our course forward through the day. And at some point, we would be taking a dead reckoning position along that course line for the next site and start the process all over. If we're doing sun sites in particular, we would be advancing lines of position from previous up to the current time to create a running fix. We're going to talk about that in more detail in the exercise on plotting. When we do a little bit more detail on plotting, we'll cover running fixes and several other possible things we might encounter when we're plotting. All right, that's plotting. The next episode will be a final problem where we will go from start to finish with a sun site, and again end up with a plot at the end, just so you can see, put all the pieces together, and it'll make sense starting from the beginning, getting all the way to the end. So thanks for stopping by the nav station. If you haven't subscribed yet, we've got a lot more episodes to come covering all the celestial bodies that you typically use in celestial navigation, including the noon site. So we look forward to having you back here for the next episode, where we'll walk through a complete site and then be off to some of our other episodes. Thanks a lot.